Hi, my name's Dan Clarke, and I'm one of the product managers here at SciMed. And I'm here today to talk to you about Hielscher Ultrasound. We're going to be covering 5 frequently asked questions for first-time ultrasound users. At SciMed, we're lucky enough to have a number of these demo units on hand for you to do a feasibility trial or loan. You just have to get in touch. Frequently asked question number 1 is, why am I not seeing the full power of my instrument displayed on the screen and transmitting to my liquid? It's an obvious one, but it's one of the most commonly asked questions. This unit has a total of 400 watts of power, but if I was to turn it on full power and sonicate this water, I might only see a coupled energy, that is the amount of energy transferred to the liquid, of 50 or perhaps 60 watts. That is because the unit will only ever draw as much power as is required to move that probe through the set amplitude. It's always key to control the amplitude, to control the power. If you're in any doubt about that, have a play, vary the power, vary the amplitude, and you will see that power draw going up and down. It's all about efficiency with Hielscher Ultrasound. That's the key to user up. Frequently asked question number 2 is, quite simply, how long do I need to sonicate my liquid and material for until I know it's done? Well, only you can really answer that question. Different processes require different amounts of energy and time and power inputs. An emulsification is a very simple process. It doesn't require much power, whereas particle disintegration requires a lot more energy. So how do you decide? Well, hopefully you've got a method of analysis for looking at your finalized material, but the key to understanding how ultrasound processes work and how much energy you need is to consider the watt seconds per milliliter. That is, how much power do I require every second for every milliliter of my total volume? We're here to help you figure that out and establish that. Once you've done that, you can scale up to any size you like, as long as you always maintain that watt seconds per milliliter. Of course, seconds are just one element, time, in that equation. Your volume and your total power output, as we covered in question 1, also plays into that. Frequently asked question number 3 is, how often do I have to replace my probe tip? Well, probe tips are made of a solid grade 5 titanium. It's really tough, corrosive resistant, and hard wearing. Hopefully, if you're not using your instrument 24/7 for production, those tips should last you for a couple of years each, at least. You can always tell the condition of a probe tip, though, by looking right at the end of the probe and studying it. It will, first of all, it will lose its shine and it will start to go matte in texture. That's absolutely fine. You'll begin to see a little bit of pitting. Again, that's fine. It's just wear and tear, just like a car tire does. It takes a long time for it to be useless. Eventually, you will start to see pitting creeping down the sides of this probe. When you see that, that's probably a good indication that it's time to change your probe. If in doubt, get in touch with us, take a photograph, send me a picture and we'll be able to help. Frequently asked question number 4 is, how do I clean my probe tip after use? Well, chances are a lot of what you're sonicating just either water or common solvents. Again, as we mentioned in our previous FAQ question, grade 5 titanium. You can just wipe it down, you can use water, you can use a mild solvent like acetone, ethanol, or IPA. As long as you wipe clean and pick off any bits of hardened crust that might be on there before you use it the second time, you're always good to go. Just a simple wipe down and keep going. Frequently asked question number 5 is, what variety of solvents can I use with my ultrasound probe? Well, there's 2 answers to this question. First of all, compatibility. Chemically, these probes are grade 5 titanium, corrosive resistance, tough as old boots. There's very little that you can't use. Avoid chlorinated solvents will be my suggestion there, but there are plenty of good websites and information with chemical compatibility with metals that you can look up. The second part of this question is think about the vapor pressure of your solvent. Does it evaporate easily? Does it have a low boiling point like ethanol? If it does, always remember that ultrasound adds heat to the environment, to the liquid that you're sonicating. So having a low boiling solvent like ethanol and heating it up, just be careful, keep an eye on that temperature, and you don't want vapor getting up underneath this unit and going into the electrics. We've got so much to say about this, we thought we'd do a bonus FAQ number 6. And that final one is about servicing and calibrating. It's a frequently asked question when people are buying or simple users. How often do I have to send this instrument away or get somebody in to service it or calibrate it? The great answer here is you can do it all yourself. The only moving part on this unit is that probe. It's not even classed as a machine. It is a device because there is just one moving part. All you need to do is when you do change this probe, which may be once every 2 years, simply go to the settings button on here, hit one menu down and hit calibrate, and it does everything else for you. I hope you found that video helpful. We're here to help you. As mentioned at the start of this video, we're lucky enough at SciMed to have a number of these demo units. If you've never used ultrasound before, you've never experienced it, but you think this can enhance your business or your products, get in touch. We have a loan diary. We can send these out for a couple of weeks at a time, or you can get in touch with us here at SciMed for a day in our labs. There's going to be information coming up on the QR code on screen, and you can also click the link in the description below.